Okay, so let's proceed to naming and writing of the rest of the classification of compounds. So again, as I have mentioned, there are also 4 classification of compounds. So we have the oxide, so we'll discuss this one. So again, it's a binary compound composed of 2 elements only, wherein one of the element is the oxygen, and it is always the anion with negatively charged, that's -2. And the other element could be metal or non-metal. And of course, the name will always end with oxide. So we have here examples. And the other one is the base, the salt, and the acid. Okay? I will be discussing first the base. Okay, after the oxide, the base. Now, when we talk of base, it could not be a binary compound. It is not a binary compound. So, it is a compound composed of, take note, a metal, because one of the chemical properties of metals, they form alkalis or they form base once it is in a compound. So, composed of a metal and the hydroxide anion. So, hydroxide has a symbol of OH and the charge is -1. Take note that is 2 elements. You have oxygen and hydrogen, and the name ends with IDE. So once it is combined with other element like metals or the non-metal polyatomic ions like the ammonium, then plus OH, ammonium hydroxide, it will not really form a binary compound. Okay? At least it is a ternary compound. But you will notice that the name will end with IDE. That's hydroxide. It ends with IDE. But it is not a binary compound. So this is hydroxides or base are actually one of the exception to the rule for the binary compound that the name ends with IDE. So base are not a binary compound, but it is named like a binary compound because it ends with IDE, but it is hydroxide. So another exception to the rule for the binary compounds that ends with IDE are the compounds of cyanide. So we know that cyanide, Cn, -1. 2 elements, you have carbon and nitrogen, so it's no longer, once it is combined with a cation, so it will not form a binary compound. But still the name ends with IDE because this one is cyanide. So IDE. So if it is, for example, combined with sodium, for example, +1, so you will have NaCN. So it is named as sodium cyanide. Okay? So you have 3 elements in it or 3 atoms in it. You have sodium, carbon, and nitrogen. So it is not a binary compound, but it is named like a binary compound because it ends with IDE. So that is another exception in the name of the binary compounds that ends with IDE. So you have the hydroxide or the base and the cyanide compound, and the other one are the compounds of ammonium. Ammonium compounds. So we know that ammonium is NH4 plus 1. Ammonium, NH4 plus 1. It is composed of nitrogen and hydrogen. Once it is combined with a monoatomic anions, for example, sulfur or chloride, for example, chlorine. So chloride is -1. So if you are going to combine that to it is monoatomic ion, it ends with IDE. So there are already 3 atoms in it, nitrogen, hydrogen, and chlorine. But the name, so if that will be combined, it is written as NH4Cl, +1, -1. But it is named as ammonium chloride. Take note, ammonium chloride. So again, it is not a binary compound, but it ends with IDE. So these are examples of a compound which are named like a binary compound because it ends with IDE. So they are exception to the rule. Okay, please take note of that one. So I'm going to clean this one. because we are going to use the board. So this is also mentioned in the notes that I uploaded. Compounds named like a binary compound. Okay? So in this case now, since we are going to name a salt which is not a binary compound and a base which are not a binary compound, so there is another rule in the formula writing and naming. So please take note of the polyatomic ions. OH hydroxide is a polyatomic ion composed of two elements, oxygen and hydrogen. So you are going to name, if formula is given, for example, NaOH, all you have to do is just mention the name of the cations followed by the word hydroxide for OH. So that is sodium hydroxide. Okay? If, for example, because OH is -1, so sodium is also +1. So the subscript is 1, 1. Now in this case, for example, you have iron, then OH3. Why you have 3 here? OH, take note, is -1. So the 3 here is the charge of the iron. So it is +3. So meaning it is the iron which has 2 charges, the +2 and the +3. Since it is 3 here, so meaning the 3 here is the charge of the iron. And take note, iron is a variable, it is a cation with a variable charges, +2 and +3. So the iron that is used here is +3. So the name of iron 3 in the classical form is ferric. So it is named as ferric hydroxide or iron 3 hydroxide. Please take note of that one. Now for example, if you are given the name and you are going to write the formula, this one is magnesium hydroxide. So the steps is the same with how we write the formula of a binary compound, but in this case, the other one, or it could be a cation or an ion, wherein it is no longer a monoatomic ion. So there is a additional rule on this one. So if you have magnesium hydroxide, so I'll just write it here. So again, it's magnesium hydroxide. So first thing you're going to do, of course, you write the symbol and the charge of the cation and the anion. Magnesium is Mg plus 2. Okay? Hydroxide is OH negative 1. Take note that hydroxide is a polyatomic ion composed of 2 elements or atoms, oxygen and hydrogen. So same process, cross indicate their oxidation state as a subscript, omit the sign. Okay? Cross indicate as a subscript, omit the sign. And also take note of the charges, reduce them into the smallest whole number, but in this case, hydroxide is always 1, negative 1, so there is no reduction of the oxidation state. Cross indicate, so the magnesium here, the subscript will be 1, and the subscript of the OH will be 2. Now, since hydroxide is a polyatomic ion, if it is a polyatomic ion, then once you're going to cross-indicate the oxidation state as a subscript, and the subscript is more than 1, you are going to enclose them in parentheses. So, OH will be enclosed in parentheses, then you will write the subscript 2. Okay? So, the chemical formula for magnesium hydroxide is MgOH. This is a polyatomic ion. Enclose it in parentheses since the subscript is more than 1. Same thing with here. Same thing here. You have OH. Then the charge of iron here is 3, so it is enclosed in parentheses. 3. Okay? So, that's how you're going to write the formula of a compound if one is a polyatomic ions, and the subscript, what you're going to cross indicate their their oxidation state as a subscript and it's more than one, you're going to enclose them in parentheses. Same with the salts, how you're going to write the formula of the salt. So a salt compound could be a binary compound, or it could be a ternary compound, or a quaternary compound. So for the binary compound, we already discussed that one under binary compound, wherein the name ends with IDE. So if it is a ternary compound or a quaternary compound, the name of the salt will end with ate or ite. And of course, there are exceptions to the rule, like the compound of cyanide. No? Like example, kaganina, it's a sodium cyanide. It's not a binary compound, but it ends with IE. So exception to the rule. So for example, we have here, you're going to write the formula of iron 3 carbonate. Okay? Iron 3 carbonate. So it ends with 8. It's a salt. So iron 3, so you have Fe plus 3. Carbonate is CO3 negative 2. Okay? Now take note, carbonate, CO3 negative 2, it is a polyatomic ion. So you have the charges here, iron plus 3, carbonate negative 2. So 3 and 2, you cannot reduce them into another whole number, smallest whole number. So there is no common divisor between 3 and 2, so you cannot reduce that one. So again, pros indicate their oxidation number as a subscript, omit the sign. So the iron here, the subscript of the iron is the charge of the carbonate, which is 2. And the subscript of the carbonate, take note, carbonate is CO3. And the subscript of the carbonate is the charge of the iron 3, which is 3. Now, since once you're going to cross it as a subscript, it's more than 1, you have to enclose this one, the polyatomic ion, in a parenthesis. Then that's the time that you're going to write the subscript. Okay, so it is 3. So the formula for iron 3 carbonate will be Fe2 enclosed in parentheses, CO3, iron 3. So same thing here, you have ammonium phosphate. Ammonium is NH4, the charge is +1. Phosphate is PO4, the charge is -3. Okay? So you have 1 and 3, cannot be reduced. Cross indicate their oxidation state as a subscript, omit the sign. Ammonium is a polyatomic ion, phosphate is a polyatomic ion. So when you write ammonium as a polyatomic ion and cross indicating the oxidation state, so the subscript of ammonium, which is NH4, is 3, it's more than 1. So you have to enclose this in parentheses, then you write 3. Okay? Then you have PO4. PO4. Phosphate is a polyatomic ion. And once you are going to cross indicate the oxidation state of ammonium, which is 1, so the subscript of phosphate will be 1. Since it is 1, you do not enclose phosphate in parentheses. Again, you are going to enclose only the polyatomic ion in parentheses once the subscript after close indicating their oxidation state is more than 1. If it is 1, no need for you to enclose them in parentheses. Okay, remember that one. So therefore, the formula of ammonium phosphate will be NH4, it is enclosed in parentheses because the subscript is more than 1. And you have PO4, phosphate, which is also a polyatomic ion, not enclosed in parentheses because the subscript for PO4 is only 1. Okay, no need for you to enclose it in parentheses. So therefore, the formula of ammonium phosphate is this one. Okay, that is the only catch if you have involved in the formula writing if it is a polyatomic ion. Just take note that if it is a polyatomic ion, then after cross-indicating the oxidation state as a subscript, and if it is more than one, enclose them in parentheses. If it is one, do not enclose it in parentheses. Okay? Let's move on to acids. Okay. Now, acid could be either a binary acid or an oxyacid, or sometimes a ternary acid. Okay? So, a binary acid, of course, it is an acid that is composed of two elements only. So, we have here the definition of the acid. So, it is actually hydrogen, which is considered as the cation, hydrogen plus 1. This is plus 1. So if I'm not going to write any number, that is understood as 1. So the nonmetals, actually, one of the chemical property of nonmetals, it will form acids. Please take note, for the metals, metal form base, OH. Non-metal form acid, so it is combined with the hydrogen as the cation, hydrogen plus 1. So, for the classification or types of the acid, it could be a binary acid or the oxyacid or a ternary acid. So, if it is a binary acid, it is composed of two elements only. And what are those elements? You have the hydrogen, which is considered as the cation, and the charge is plus 1. And the other element is a non-metal. So, there are only few non-metals that commonly form an acid, like the sulfur, the chlorine, the phosphorus, nitrogen. Okay? So for a binary acid, the name, there will be a prefix hydro. So this is one thing that you are going to remember, is the name of the acid starts with the prefix hydro. It is a binary acid. And if it is a binary acid, it will always end with IC, ic. The suffix is IC. The prefix is hydro. Then the stem name of the non-metal with a suffix of ic followed by the word acid. And the acid will be formed only once it is in a solution. No? It is combined with water. So it is in the solution, then it becomes acidic. So for example, if you have chlorine, where is the example? I don't have chlorine here. Here. It should be hydro. Okay, here. So this is two examples. So if you have the name given as starts with hydro, it ends with ic. Okay? Hydro, ic, followed by the word acid. So of course it is an acid, it ends with the word acid. So it indicates that it is a binary acid because of the prefix hydro. And it ends with ic. So all binary acid will end with ic acid, that is hydroic acid. In the middle, that is this indicates what non-metal is being combined with hydrogen. So it is chlor, so meaning that is chlorine. So therefore, the formula of hydrochloric acid is, it is a combination of hydrogen, which is plus 1, and chlorine, that's chloride. That's chloride. So it will be the hydrogen, because it is an acid, plus then that is chlor. You check on the charge of chlorine in the periodic table. As monoatomic an ion, it's negative 1. This is plus 1, negative 1. So cross indicate. So the formula of hydrochloric acid will be HCl. Okay? That's hydrochloric acid. The second example is you are going to give the name. So I wrote there H2S. This is in water. Because if I'm not going to write this one in water, you can name this one as a salt, not as an acid. But if there is in water, that is understood that you are going to name this one as an acid. Because if it is not in solution, you can name it as a salt. And that is named as hydrogen sulfide. If it is an acid, then you follow the rules on naming the acid. Since there are two elements only, the hydrogen and the non-metal, so therefore it is a binary acid. So if it is a binary acid, it starts with hydro. That is the prefix. There will be hydro. And of course, it ends with IC followed by the word acid. So you have to get the stream name of the non-metal. The non-metal here is sulfur. So it will be named as sulfur, then connect IC. So that will be named as hydrosulfuric, then followed by the word acid. Okay? So it's hydrosulfuric acid. Take note, prefix hydro, suffix ic, stream name of the non-metal, followed by the word acid. You might ask why there is 2 here. What is 2 here? The 2 here is the charge of the sulfur as an ion, and that is -2, because hydrogen is always +1 as cation. Right? Sulfide, so that is -2, so the formula is H2S. Okay? So this is example for a binary acid. For the oxyacid, take note, oxyacid, so meaning it is a ternary acid. It is a combination of the hydrogen, of course, because if you're going to define hydrogen, it is a compound that will ionize in water and produces hydrogen ions. While the base is a compound that will ionize in water that will produce the hydroxide ion. Okay? But that will be discussed also in our other topics, the acids and the base. So, oxyacid, it is also known as ternary acid because it is composed of 3 elements. So, it is composed of the hydrogen and the oxy and ion. Take note that oxy and ion, these are polyatomic ions, which is composed of the non-metal and oxygen. Non-metal and oxygen. For example, if you have sulfate. Now, for example, if you have SO4, -2, that is an oxy and ion, you have sulfur and oxygen. Another example, you can have NO3, -1, nitrogen and oxygen. So these are oxy and ion. So once it will combine with hydrogen, it will form, there will be 3 atoms in it. If it is combined with sulfate, SO4, there will be 3 atoms or elements in it. You have hydrogen, sulfur, and oxygen. If hydrogen is combined with NO3, there will be 3 elements in it. Hydrogen, nitrogen, and oxygen. So that is ternary acid. If it is hydrogen is combined with oxy, take note, oxy and ion. And we know that the oxy and ion name ends with either -ate or -ite. For example, the SO4, it is named as sulfate. The SO3 is named as sulfide. SO3 -2, it is sulfide. SO4 -2, it is sulfate. I hope you follow this one. Take note. So, again, so if to name it, the name of the, there will be two types of naming here, 2 kinds of naming. It depends on the suffix of the oxy and ion. If the oxy and ion end with -ate, the name of the acid will be ic acid. So there will be a suffix of ic followed by the word acid. No prefix hydro. So the prefix hydro here indicates that it is a binary acid. If it is already a ternary acid, there will be no more prefix hydro. Take note of that one. So one name of the acid, oxyacid, if the if the oxy and ion end with ate, like sulfate, phosphate, nitrate, chlorate, it ends with ate, the name of the acid will have a suffix of "ic" followed by the word acid. So the blank here is the stream name of the non-metal. So for example, sulfate, the non-metal here is sulfur, nitrate, nitrogen. Okay? So if the oxy and ion end with ite, ite, the name of the acid will be os acid. Stream name of the non-metal with the suffix os followed by the word acid. For example, so if you have here H2SO4 in water, so meaning you are going to name it as an acid. Again, if there is no in water, you can name it as salt, and it is named as hydrogen sulfate. But if it is in water, you are going to name it as an acid. So since it is hydrogen, take note of this one. Hydrogen, we know that hydrogen is class 1. Combined with the oxy, this one is the oxy and ion, which is SO4 negative 2. That is why the formula is H2SO4. Cross indicate their oxidation state as a subscript, omit the sign. So the subscript now of hydrogen is 2. Of course, sulfate will be, and the other element in the acid will be always 1 as a subscript because hydrogen is 1. So what will vary actually in terms of the number of ions here in the acid under acid is the number of atoms of the hydrogen. It's the variable. So SO4, it is sulfate. So it ends with 8. It ends with 8. So therefore, the name of this acid will have a suffix of "ic" followed by the word acid. So that will be, this will be named now as, so take note, you have stream name of the non-metal with the suffix "ic" followed by the word acid. Because the oxy and ions here, SO4 ends with 8. So this will be named as, the stream name of the sulfur, it's still sulfur. So you have sulfur, then with the suffix "ic" followed by the word acid. So it is named as sulfuric acid. Take note of the difference between H2SO4 and H2S as an acid. This one is a binary acid. It has a prefix hydro. Hydrosulfuric acid. This one is an oxy acid, so there will be no prefix hydro. So it is just named as sulfuric acid. Why "ic"? Because the oxy and ion combined with hydrogen and with 8. Okay. Second example. Take note, you have H2SO4, H2SO3. So this one is sulfate, this one is sulfite. So again, you have here the hydrogen plus 1, then the oxy and ion SO3 negative 2. So the formula will be H2SO3. The name of SO3 is sulfite, this one, sulfite. It ends with "ite." So the suffix for the name of the acid will be os. Okay, os. And the stream name, so that will be blank, stream name, then os acid. So H2SO3 will be named as sulfur, then os, followed by the word acid. So this is sulfurous acid. So H2SO3 is sulfurous acid, H2SO4 is sulfuric acid. Okay. The third example, you are going to give the formula of nitric acid. So if the given is the name of the acid, you are going to consider 3. First is, check on the name whether there is a prefix hydro. If there is no prefix hydro, then it ends with either "ic" or "os. Then it is an oxy acid. Okay? So the name here is nitric acid. No prefix hydro. So therefore, it is not a binary acid. So therefore, if it is not a binary acid and it ends with ik or os, then it is hydrogen plus 1 combined with an oxy and ion. And how are you going to determine the oxy and ion? How are you going to determine the formula of the oxy and ion? Take note of the name of the acid, nitric. It ends with ik. So therefore, the name of the oxy and ion ends with 8. Okay, ends with 8. So probably this will be nitrate. It ends with 8 because the name of the acid ends with IC. So therefore, the oxy and ion that will be combined with hydrogen ends with 8. So the possible here, since that is nitrate, so that nitrate, nitrogen. So you have to look for the symbols for any oxy and ion which is composed of nitrogen and oxygen that ends with 8. Okay? So there are only 2. So you have the nitrate, the NO3, and NO2. The charge here is -1, -1. NO3 is the nitrate. NO2 is the nitrite. So this one is nitrite. It ends with ITE. This one is nitrate. It ends with 8. So therefore, the oxy and ion that is combined with hydrogen to form a nitric acid is NO3 -1. Okay? Then you write the formula. Based on the charges, these are all 1, 1, so this can be reduced to 1, of course. So the formula of nitric acid then will be HNO3. Okay? Get it? That's the formula of nitric acid. The last example, phosphorus acid. So again, check on the prefix whether there is a hydro or none. So again, if there is no hydro prefix, so meaning it is not a binary acid. And it ends with os. So it is an oxy acid, and of course it's a ternary acid. It ends with os. You have phosphorus acid. So again, it's not a binary acid. So it is an acid. So you will have the hydrogen combined with the oxy acid. Oxy and ion. So take note of the oxy and ion. So you have phosphorus. So the non-metal here is phosphorus. So it's an oxy and ion, so you have to look for the oxy and ion, the phosphorus, that is combined with oxygen. And the oxy and ion will end with ite because it is os. Take note, if it is os, the oxy and ion will end with ite. So check on your list of anions, what are the oxy and ions. It's a combination of phosphorus and oxygen that ends with ite. So, 2. You have the phosphate and the phosphite. So, of course, that will be the phosphite because it ends with os. And what is the symbol and charge of phosphite? Phosphite is PO3, -3. The PO4, -3 is phosphate. So, therefore, the oxy and ion that will combine with hydrogen here to form phosphorus acid is the PO3 -3. This is phosphite. So this one is phosphite. So that's ITE, so it will end with os. So therefore, the formula of phosphorus acid will be, cross indicate their oxidation state as a subscript, omit the sign. So therefore, the formula of phosphorus acid will be H3. 3 here stands for the charge of the phosphate. Then PO4. Again, the subscript of PO4 is 1 from the charge of the hydrogen. Do not enclose it in parentheses. So therefore, this is now the formula of phosphorus acid. Okay? So that ends for the naming of the inorganic compound from binary compound to oxide to base to salt and to acid. Please study the video, and if you have question regarding on it, we'll meet on Monday 7:30 a.m. There will be another video coming about chemical equation. So it's balancing types of chemical equation, and after that we'll proceed to